We saw that we can solve systems of equations by graphing, and it's very easy to do, but sometimes it's just not very accurate. So we're going to explore another way to solve systems of equations, and that is by substitution. So this substitution method is very concrete, it's very sequential, and you will be able to follow these steps easily. The goal when you're using substitution is to get the system so that you only have one equation with one variable. Then you can solve it by using inverse operations to isolate the variable. Here are the steps. You will probably want to write this down. Step number 1, isolate. Get at least one variable by itself. Step 2, substitute. Take the equation that you just isolated the variable for and substitute it in for that variable in the other equation. Then solve that equation using inverse operations. Take the answer that you get for that variable, substitute it back into the first equation where you isolated the variable, and then solve for the remaining variable. Make sure that you check your answer, and whether you check your answer by graphing it and checking it that way or by substituting it into both equations and making sure it works, either way is fine. So let's try some and apply those. You'll notice that I just gave you the initial letter of the step over here on the side. So ready? Isolate one of the variables. In this case, these are both isolated already. Some people prefer to go ahead and take both equations and put them in slope-intercept form. Then you're going to take this value right here and substitute it into the second equation in place of the y. That will give you the equation 3x is equal to x minus 2. So step 1, isolate. Step 2, substitute it in place of the other variable. Step 3, we're now going to solve this equation. We subtract x from both sides. That's going to give me 2x is equal to negative 2. We're going to divide both sides by 2, which is going to give me x is equal to negative 1. Now that I know that x is equal to negative 1, I'm going to substitute the negative 1 back here in the original equation. So that's going to give me y is equal to 3 times negative 1. I'm going to solve that and get y is equal to negative 3. There's the second part of my answer. So my solution to this system is negative 1, negative 3, and now I need to check it. So go back to my original equation. So let's erase this so we've got something clear to work with here. Okay, and substitute that in. Put a negative 1 in place of x here and here, and put a negative 3 in place of y, and see if it works. Ready? 3 times negative 1 is negative 3, worked in that one. Negative 1 minus 2 is negative 3, worked in that one, so there it's done. We're just going to do a couple of these problems, and again, the steps are listed on the side, so you're going to want to pause the video for each one, work it out, and then check it with my work. Okay? Number 1, this one is already isolated, so I'm going to use y is equal to x plus 1. Let's minimize the work. If you already have a variable that's isolated, use that. Step 2, substitute x plus 1 in place of y in the second equation. So that's 4x plus, the y comes out, this x plus 1 goes in its place, is equal to 6. Now let's solve. These parentheses were just to show you that that whole entire x plus 1 went in place of the y. So now this is going to give me what? 5x plus 1 is equal to 6. Subtract 1 from both sides. 5x is equal to 5. Divide both sides by 5. X is equal to 1. Okay, so isolate, substitute, solve. Now I'm going to substitute back into this original one, which is y is equal to, x comes out, 1 goes in its place, and then that was plus 1. And now I'm going to solve this, which is going to give me y is equal to 2. So there it is. So my solution is the point 1, 2, and I go back in here and check my work. So put a 1 here, a 2 here, a 1 here, a 2 here. Ready? 1 plus 1 is 2. Yep. 4 times 1 is 4, plus 2 is 6. Yep, and we are done there. Okay, try this one. Okay, now I have some choices. Here, they're not already isolated, so I can either use this x, this y, or this y. Pick one that's easy. I would either choose this x on the top or this x on the bottom. I probably would choose this one. So plus y. So that's going to give me x is equal to y plus 5. Isolate the variable. Go to the other equation. Take the x out and put y plus 5 in its spot. So y plus 5 is going to go here. Y plus 5 is going to go there where the x was, and the rest of the equation stays the same. And you see now I have one equation with one variable. I can solve this. Ready? Let's clean this up. 3y plus 5 is equal to negative 1. Subtract 5 from both sides. 3y is equal to negative 6. Divide both sides by 3. Y is equal to negative 2. There's half my answer. Okay? Now that I know that y is equal to negative 2, go right back here and put the negative 2 in place of the y. So that's going to give me x is equal to negative 2 plus 5. Solve that. X is equal to 3. There's the second part of my answer. And check it. Put a 3 here. Put a negative 2 here. Put a 3 here. Put a negative 2 here. Ready? 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. Check. 3 minus a negative 2 minus a negative is plus. 3 plus 2 is 5. Check. We did well. Okay? Just a word of caution. When you substitute, when you solve one equation and you get an answer, you don't substitute back into itself because that's always going to work. You need to substitute into the other equation, not the one that you just used. All right, so here's a word problem, and then we're finished. Jen is deciding between two cell phone plans. The first plan has a $50 sign-up fee and costs $20 per month. Okay, so I'm thinking that's my y-intercept. That is my slope. The second plan has a $30 sign-up fee right up front and costs $25 per month. After how many months will the total cost be the same? What will the cost be? If Jenna has to sign a one-year contract, which plan will be cheaper? And explain. Now, this is one of the big benefits of learning systems of equations is solving word problems. I'm going to write two equations using two variables. So I'm going to start with the first one. Ready? So this first plan is a $50 sign-up fee plus $20 a month. The second plan is a $30 sign-up fee plus $25 per month. I want to link these together and find the XY value that works for both of them. When you find that XY value that works for both of them, that's where the two plans are exactly the same. So in this case, this is one of those where they're both solved for y, so I simply take this, substitute in here for y, which is going to give me 20x plus 50 is equal to 25x plus 30. Now let's solve this. Let's subtract 20x from both sides. Let's go ahead and subtract 30 from both sides at the same time. That's going to give me 20 is equal to 5x. Divide both sides by 5. X is equal to 4. So 4 is the number of months where the plans will be the same. Okay? Take this 4. Let's put it right in here. 20 times 4 is 80. 80 plus 50 is 130. So y is equal to 130. Now, what does that mean? It means in 4 months, both plans will have cost me $130. So let's answer the questions though now. Okay? After how many months will the total cost be the same? 4 months. What will the cost be? $130. If Jenna has to sign a one-year contract, which plan will be cheaper? Well, which plan is cheaper per month? The top one. So that would be the top one there, okay? Because at 4 months, they're both the same. After that, the one that has the smaller slope or the cheaper per month cost will be the cheaper, okay? And that's it.